Hey there, and welcome to our last video. This is all about law, sines, and cosines. This isn't going to be too crazy hard. The hardest part about this is to know, should I use law sines and use law cosines? And hopefully by the end you kind of have a good idea of when I should use which one. So the purpose of law sines and cosines is to use for triangles that are not right triangles, because we have the regular sine, cosine, and tangent for those kinds of ones. So these are going to be useful for our non-right triangles. All right, let's just go ahead and jump right into it. All right, so we have ourselves a law of sines. So go ahead and get this written into your notebook. It's A over sine of A, B over sine of B equals C over sine of C. And so what that relates to is any triangle. It could even be a right triangle. It would work for a right triangle, but we typically don't need to do it for that. But what I want you to notice there is you're going to have three angles. And so we're using A, B, and C as what we're going to be doing with this, but it doesn't have to be A, B, and C. It could be D, E, F, G, H, I, all those letters there. Okay, but it's essentially the A on the top is the side that's across from the angle A. So if instead I had this being like angle D, okay, then this is going to be little d, all right? So that's kind of how we're going to think about that. So we always set up each fraction or ratio where the side that's across from the angle goes on top of each other, okay? So again, A, B, and C are all our sides. Capital A, capital B, and capital C are all of our angles, okay? So like I said, instead of focusing on A, B's, and C's, we're going to think about things to the opposites, okay? All right, so let's go ahead and take a look at why that works. And so I'm giving you everything here just to kind of emphasize why everything is equal. And so when I set it up here, the sine of A, we're going to choose one of the sides, so I chose 8. So that's going to be 8 over sine of 62.2. If I were to simplify that down into a decimal, I get about 9.04. And the same thing is going to happen when I did the opposite of 5 over sine of 33.5, and as well as the 9 over 84.3. Okay, as you can see, all of them are about the same. So why are they somewhat different? It's all because of the actual decimals that are found in our thing there. The 84.3 is probably rounded at some point, 33.5, and so on. Okay, so just kind of be aware of that. Okay, so let's go ahead. We have two types of things that we can do for calculating. We can find an angle or we can find a side. So for finding sides, they're a little bit easier than finding angles, because angles we're going to have to use inverses. Okay, so when you're going to be doing these, again, my triangles are going to have A, B, C, but essentially what we want to do is substitute in everything that we know into our stuff. Okay, so I have angle B is across from 7, so those are going to go on top of each other. I have C, which is what we're trying to find, over sine of 105, and then I don't have anything about angle A. So let's go ahead and take out that useless stuff. So what we have is 7 over sine of 35, so that's one of our pair of opposites, equals C, which is what we're solving for, over sine of 105. Okay, so from here we're going to cross multiply. So we're going to get 7 times sine of 105 equals C times sine of 35. And so I went ahead and multiplied it out now. You could multiply it out later. Now there's rounding involved, so if your answers are slightly off, just keep that in mind too as well. Okay? All right, so to solve for C, we're going to divide both sides, and we get the answer of 11.787. Okay? So again, like I said, solving for a side is nice and easy. So let's go ahead now and do when we're calculating for an angle. All right, as like I said before, we're always looking for a pair of opposites. That's how we know we're going to be using our sine, our law of sines. And so I have the 5.5 over 63, or over the sine of 63 degrees, and then I'm solving for angle B, so 4.7 is going on the top, okay? So if we were to fill out everything, I don't have anything again about angle A, so we don't really need to write that down at all. And we have 4.7 over sine of B equals 5.5 over sine of 63. Okay, this is where things start to get different. In the previous one, we cross-multiplied, and then we were done. In this one, though, I'm solving for an angle. So we're still going to cross-multiply. That's not different. We're still going to divide. When I multiply and divide, I end up with the answer of 0.7614. Okay, so this is not the angle measure. This is sine of B equals the 0.7614. So let's think back a couple of sections ago. When we're solving for the angle, we have to do the inverse. So if you're ever calculating angle and you're not doing an inverse, you've done something wrong. So we're going to flop spots. Okay, so that we have ourselves the sine inverse of the 0.7614, and then this becomes a plug and chug. So we're going to substitute that in, and we get about 49.6 degrees. So that means angle B is about 49.6 degrees. Okay? All right, let's take a look at our law of cosine. So this is a little bit different. Law of sines, we had to have a pair of opposites. Sometimes you might be able to solve for the pair of opposites, meaning like I gave you two of the angles, you might be able to solve for the third angle. That's going to be kind of the hardest thing to do about that, all right? Law of cosines, while there's three written here, it's all saying the exact same thing, okay? What I want you to notice is that this piece out here and this angle in the back matches, okay? Everything inside is the remaining pieces. So we don't have to memorize c squared equals a squared plus b squared minus 2ab cosine c. B squared equals a squared plus c squared minus 2ac cosine b. So what you want to do is essentially memorize one of them, although you're probably going to get the one of them on the test. And keep in mind here is that this guy out front and this guy out back is essentially going to be, this is going to be the same pair of opposites. And whatever you're solving for is what goes in that spot. So if I was solving for side B, you would be using this one. If you were solving for angle A, you would be using that one. So the ones on the outsides are the pieces that you're going to be solving for. Okay? So again, A, B, and C are all sides. Big A, B, C, or capital A, B, C are all the angles. So let's go ahead and do two examples with that. So one's going to be finding a side, and one of them is going to be finding the angle, okay? Now, with these, we typically don't have a pair of opposites. So I want you to take a look at this. I've got 11, the angle 37, and 8. And I'm solving for the side that's opposite of 37. I'm not given a pair of opposites, so I don't have numbers as a pair of opposites. And that's what clue to you to use the law of cosines, okay? So you can see the side angle side stuff there, that's a clue to you to using law of cosines, okay? So again, the key thing here is that I'm solving for the angle that's across from C. Let's remind ourselves of what we got going on here. We have c squared equals a squared plus b squared minus 2ab cosine c. Calculating sides, like I said, are always easier than calculating the angles. So since I used the C one because we're solving for C, and I got angle C on the opposite side there. So from here, we're just going to substitute our values. Now, for the sake of the problem here, we're going to use the fact that this is angle A, so this is going to be little a. This is angle B, so this is going to be little b. But it doesn't matter which one is which. You could have done 11 squared plus 8 squared, or you can do 8 squared plus 11 squared. Same thing with the minus 2ab. You can do minus 2 times 11 times 8 or minus 2 times 8 times 11. It does not matter. So let's go ahead and substitute those values in. And end up with c squared equals 8 squared plus 11 squared minus 2 times 8 times 11 cosine of 37. The nice thing about this is it becomes a plug and chug when you're solving for sides. You can just go ahead and substitute or write this whole thing in if you have a graphing calculator or a calculator that lets you multiply and add and subtract and do all that stuff all in one sitting. So you can just stick it in that calculator and get a number. If you don't, though, you might have to go through and do it one at a time. So square out the numbers, multiply 2 times 8 times 11, and then combine everything together. So again, this is c squared, this is not c, so we need to finish this up by taking the square root of both sides, okay? So the value of c in this is 6.67. Calculating sides are pretty straightforward. Let's now take a look one where we're calculating an angle. It's a little bit different here, okay? So calculating a side, it's probably going to give you side, angle, side. Calculating angle, we're going to have all three sides, and we're not going to have any of the angles, okay? So, again, I'm going to use the C because I'm finding angle C, but once again, it doesn't matter. I could have ignored the fact that letters exist. I'm looking at that, I'm finding this angle and that side. So if I didn't even have any of this, then I would go ahead and just substitute values into that same thing in general, and where the C, the 8, and the angle C is what's on the outside here and the outside there, okay? Anyways, so the first thing we need to do is go ahead and substitute all those values in. Again, I'm going to use the fact that the 5 is across from B to call it little b. Actually, in here you can see I didn't really do that. 5 is A and B is 9. Again, it doesn't matter. Okay, the big thing that matters here is that the C is 8. That's the one that counts because that has a specific spot to go. The 5 and the 9, it's not going to matter. So let's go ahead and substitute in those values. And so I have 8 squared equals 5 squared plus 9 squared minus 2 times 5 times 9. Once again, it doesn't matter the order of the 5 or the 9. All right, here's where things get different than the one where we're calculating C. We can't just plug and chug. You can't just do 5 squared plus 9 squared minus 2 times 5 times 9. That is a big no-no. So you're going to have to go through and actually do it one step at a time here, okay? So let's simplify first. 8 squared, 5 squared, 9 squared, and then the 2 times 5 times 9. So that's your first step, okay? Go through and actually multiply things out, but don't combine anything yet, okay? So now I'm at that point where I'm going to start combining things. So the 25 and the 81, I'm going to start moving that over to the left-hand side. Notice how I did not move the thing next to the 90. If you're getting these problems wrong, it's probably because you did the 25 plus 81 minus 90. Order of operations does not allow us to do that. Okay, so you're going to move the two numbers that are squared out over, but don't move the 2 times a times b part. You're going to divide that now. So negative 42 divided by negative 90, and we get 0.4667. So now we're at the point where we have to do the inverse. So we're going to do the inverse cosine of 0.4667, and we get 62.2 degrees. Okay? So I know that was quite a bit to take in with the 4 different types. All right, we've got law of sines where you're finding a side or an angle, law of cosines where you're finding a side and an angle. Remember, whenever you're finding an angle, if you don't do an inverse, then you've done something wrong. Okay, now for the most part, the other problems are pretty simple. It's just this part that I know that most students get tripped up on. Okay, so be careful when you're solving these. Hopefully you're listening to this and not just watching the video. Okay, you want to combine and move and then divide before you take the inverse. Okay, all right, so some just rule of thumbs here. When do I use law of sines, law of cosines? For law of sines, you usually are given side-side angle or angle side or angle side angle. Okay, the big thing here is that you can see a pair of opposites. You got an angle across from a side. Now if you're given a case of angle side, then you can solve for the third angle, or even angle side angle. You can solve for the third angle because it adds up to 180. So keep that in mind because sometimes you're going to have to do that. For law of cosines, you're typically given side angle side or side. We don't have a pair of opposites. So that's the clue to you of I'm going to use law of sines here, or I'm going to use law of cosines, okay? All right, go ahead and hit the stop button and start working on that practice. Please make sure you're getting any help that you might need.